Hello, everybody. Welcome to you guess what? Another Kubefirst live. Uh, you know what? Really happy to be here. I have some kind of like hectic day. It's a weird day for me, so I'm glad to like have the time to be in something that feels normal for today, which is a live stream with you. So how is life, John?
Life is great, Fred. It's been a crazy week, a crazy day for me also. I thought this demo was going to be super easy to set up, and it turned out to have a little bit of intrigue to it, we'll call it. But I'm excited to show a little bit of external secrets operator today. I think we've got what should be a pretty smooth demo. And yeah, my buddy Jared, right before I hopped into the live stream lobby, he whispered to me to tell you to keep your eyes on Slack, and if anything goes sideways, it'll help us out. So, but yeah, doing great. Excited for Navigate next week. Going out to go see the great folks at SIBO, and yeah, let's get to it. You know, we're going to be talking about some new stuff today with. You know, we've got the secrets engine in Vault that's the default secrets manager for the platform. And some people have secrets elsewhere. And we have that story accommodated. We don't talk about it because our default opinion is that HashiCorp Vault is just a great enterprise secrets manager that you can self-host and works really frictionlessly with the platform. But that doesn't mean that, you know, users that want to use Kubefirst don't have apps that are, you know, in from legacy days or whatever. They're all set up in AWS SSM parameter store for secrets and configuration storage and stuff like that. So
Yeah.
Today we're looking forward to just kind of talking through what it looks like to change out Vault and swap it with a cloud-backed secret storage. We're going to show AWS parameter store today. But the exact same concept applies to GCP, who also has their own secret and config storage backends. Looking forward to
it. I think it's a great idea because we made some choices when it comes to the toolings we're using, because at some point we need to make those choices because we want to give you like a platform that is working, that I always say and repeat myself, that is production ready, that you have the tools you need to go in production and be successful right from the start, like having a real management cluster on Kubernetes that takes you like just a couple of minutes compared to like days, weeks, months, even if you're new to the cloud native world. But yeah, we made those decisions, and you may not agree with some of those. So I think it's a great opportunity for you to see how you can change some of like the toolings that we're using. I mean, we've done the same thing recently with the live stream about like using GitLab, the self-hosted. If you don't want to use, GitLab SaaS or GitHub SaaS, like there is a way for you to do that. It's not out of the box, but we want to be transparent, like about how to do that. So I think it's pretty good. And you know what, especially with Vault, I still love Vault, but with the announcement a couple of like weeks or months ago, like maybe some people want to use also other stores, providers. So I think there's going to be a great opportunity. So just before we move to your screen, let's say hi to our very own Patrick.
Yeah. Patrick. We can always count on Patrick. I love it. I love Patrick's here every time.
Always. And Patrick, it's not just on that live stream. I'm doing my DevRel show every other Thursday that we're not doing this live stream. And guess who said hi on the last show? It was Patrick. So
what a guy.
What a guy. So amazing. So you know what? Let's jump to it.
Let's do. We got a fun one today. So the first thing that I want to just kind of make everybody aware of is a lot of the work that we're going to be doing today is related to the external secrets operator. The external secrets operator is you can get to their docs at externalsecrets.io. They're a really important platform abstraction layer. Is how I usually refer to ESO. when you're when you're building a platform for your developers, when you're building a platform for your developers are going to have opinions. They're going to want their secrets in certain places, and you as a platform team may be able to establish that your secrets manager for your platform is going to be HashiCorp Vault, period. And maybe that's a good idea today. And maybe the entire organization listens to you as a platform engineer and says, okay, if you want us to keep our secrets in HashiCorp Vault, we'll keep them in HashiCorp Vault. Now you have an opportunity without external secrets operator. If you want, you can just buy into Vault, and every single application that you write, that you develop, that needs secrets, you can set up a Vault sidecar to pull secrets directly out of Vault and make them available to your application. And that would be fine to do if you were certain, 100% certain, that you're going to be on HashiCorp Vault forever. The problem is that that's a risk that you're imposing on your platform. And the reality is that due to license changes, that due to any other reason, you may decide that there's a different technology that you want to invest in for your secrets management. And to make a change like that can either have no impact on your developers, or it can have an extremely major impact on your developers. And if you tie your applications directly to your secrets manager, then you're basically handcuffing your project to the technology in a way that if you ever wanted to change your secrets storage solution, you have to go around and update every single application and do a whole bunch of stuff. Not ideal. External secrets operator works as a shim in between your secrets manager, whatever your secrets manager is, and Kubernetes. So basically, whatever you consider to be your best secrets manager solution, it might be cloud storage, it might be HashiCorp Vault, it may be any number of other secrets manager solutions. You're going to keep your secrets in there. And in order to turn them into Kubernetes secrets, you can use external secrets operator. That's its purpose. So when you do a Kubefirst install, we deliver you HashiCorp Vault. We also deliver external secrets operator to your management cluster and all your workload clusters as well. And we have it set up so that no secret through the entire platform, nor through all of the applications on that platform, nothing is interacting directly with Vault. Everything is just expecting there to be a Kubernetes secret that's available for it. And we put the ownership on external secrets operator to pull secrets out of the source of truth and make them available to Kubernetes. So to show you in real terms what that means, today, this is a new, we're going to be using the Kubefirst.com domain today as our test domain. Important to call out that this is not Kubefirst. This is just a fun Kubefirst that we're playing with. This is the equivalent of your self-hosted environment and your GitHub organization.
You would not believe the number and the type of like domain name and GitHub organizations that we have internally, like to do your testing on different platforms and different clouds and stuff. Like I need to say, John and Jared are the ones buying the domain, and they're quite creative with the word like Kubernetes, Kubefirst, and like things around like GitOps. So yeah.
It is one of the most fun aspects of the job is the branding of domains. Every time we get handcuffed into a situation where we need a new one, that is just a good day. So in any event, you can see that this GitOps repo, when you provision Kubefirst, we give you a GitOps repo. You can see this repo is only 1 hour old. We created it and then used it to bootstrap your management cluster. Your management cluster came with Vault and external secrets operator. And then we also deliver this sample application called Metaphor that uses external secrets operator in order to get secrets out of Vault. And let's just set the table and show that reality real quick. So in secret here, we have, this is HashiCorp Vault. We have a secret in here for Metaphor. It's just a sample. These aren't obviously real secrets in your actual application. These would be sensitive values. You wouldn't want to show them on screen, etc. For demo purposes, these are not actual secrets. So here we have secret 1 and secret 2, and they have values of development secret 1 and development secret 2. And if we go over to Metaphor development here, you can see that secret 1 and secret 2 are sample application. We actually show the secrets right on screen so that it's easier to demo to you guys. If, for example, we wanted to change those values in Vault, let's do that real quick and change this value from development secret 2 to development secret 2 live stream or whatever. When we hit
secret.
Yeah. And so when we save this, I'm going to hop into Argo CD real quick and go to Metaphor development environment, Metaphor. And here you can see there's this external secret that every 10 seconds pulses. And what that's doing is that's checking in with HashiCorp Vault, checking for any updates to the secret. And then whenever there's an update, it makes the secret known as a native Kubernetes secret. And we happen to have the Metaphor development application set up to read from that Kubernetes secret so that it can present to you what the value is on screen. Since we just changed that value, if I hit delete, let me scale back up, and restart that pod in just a second. I got it running, but not yet.
Since we just changed it, we are doing that now for the sake of the demo. But like someone like you wouldn't have to do that in a real life scenario unless you need the secrets now.
That's correct.
Like at some point, it's gonna sync, and you're gonna have like the updated secret. And by the way, John is like quickly showing how it's working for the sake of like you need that bit of knowledge to understand like what we're going to do to replace it. But we also did a full live stream on secret management in Kubefirst. I'm sorry, I don't have like a short link URL right now, or just search secret management on our YouTube channel. We talk about like all the intersect part and really how it's working from A to Z for probably an hour and a half, knowing your score when it comes to live stream.
Yep. Yeah, no, that's a great call out. I appreciate that, Fred. So we got the new pod available. And now if I go here, it used to be development secret 1. And when I hit refresh, now it's, or we changed development secret 2. Now it's development secret 2 live stream. Okay, so that's how external secrets operator works. It reaches into whatever you consider your secret store to be. It keeps those up to date and turns them into Kubernetes secrets. And then your application is able to interact directly with Kubernetes to get its secret information. Simple stuff and great abstraction technology. Now, when we deliver Kubefirst to you, we have everything with external secrets operators set up so that it is set up with a secret store that is registered with HashiCorp Vault with authentication already set up for you so that you can just pull those secrets and everything's ready to go just by dropping custom resources in your GitOps repository. But today we're going to change the secret source for the secrets that Metaphor is using. So we're not going to use Vault anymore for Metaphor development. We're going to change the secret store to a new backend that's going to be an AWS SSM parameter store. And then we're going to create a new external secret that can pull from AWS instead of pulling from HashiCorp Vault. And then we'll see if it all works. I think it will. So the first thing that we're going to need to do when replacing Vault with a backend parameter store is we have to make that parameter store available. So right now, for example, if I hop into AWS, and go to System Manager. And I'm going to be running my demo today out of East 2. And you can see in Parameter Store that we currently have nothing at all in here. There's no secrets stored yet. So let's fix that. Let's create our first couple secrets in AWS. But let's do it the right way. I could just go through here and click and create a whole bunch of secrets. We're going to do this through Terraform instead, just to sort of show that if you wanted to, you could. And there's a decision that has to be made. This is kind of important to understand. Every organization is going to be different in their opinion about what they want their source of truth for secrets to be, and how they want to manage the rotation and the life cycle of those secrets. Some shops will be okay saying, we're just going to set up our secrets in SSM parameter store, and that's our source of truth. And we're okay just click opsing in the cloud and creating all the secrets that we need. And by doing so, whatever needs to use those secrets, that'll all be terraformed. That'll all be infrastructure as code oriented. But the secrets themselves, we're just going to treat those secrets as pets in the cloud. And whenever we need to edit them, we're just going to hop into the console and change the value. And if it's important to retain all of the secrets, you can set up your SSM parameter store so that there's version history so that you can always go back to previous versions and protect yourself nicely. It's not a terrible ClickOps story for secrets in SSM parameter store. You could argue that you can do the exact same thing in HashiCorp Vault. You could go into Vault and just create a new secret, give it some values, and you're treating Vault in that case as the source of truth. You can also deviate from that pattern and say, I don't want people ClickOpsing ever, not even for my secret source of truth. And for that paradigm, a lot of folks will lean on IAC, something like Terraform, in order to create the secrets in their secret source of truth. But what that does is it changes the source of truth from the cloud or from Vault to Terraform being the source of truth for how secrets get generated. And you can generate random, excuse me, you can generate random passwords and store them in Vault. You can generate random passwords in Terraform and store them in AWS. And what's nice about setting it up that way is that you're able to then, if you needed to replicate your entire cloud environment in a new AWS account or something like that, you could just rerun your Terraform and it's going to regenerate a whole bunch of new passwords for that new account. And then you've got all of your IAC scaffolding set up to read from that. So it both creates the secrets that you need and then it pulls the secrets that you need. So anyway, just a little bit of conversational detail there. I wanted to sort of make clear about the different paradigms that you can have for that lifecycle management of your secret source of truth.
And Jared was saying also there's a scenario where you're migrating off a parameter store secrets manager and adopting Vault. So
that's a really good point.
Is good too.
Yep, yeah. And you can kind of, because external secrets operator works the way that it works, you can be a little bit flippant about what your technology is that you're storing your secrets in, because none of the applications have that dependency on the technology. They're all just leaning on external secrets operator to have a store that they can pull secrets from. And we're about to show exactly what that looks like. So let's go ahead and set up our first SSM parameter store secrets in Terraform. So when you get a new GitOps repository, I just cloned this a moment ago. This is the GitOps repo that we give you when you start your newly provisioned Kubefirst. And down here, there's a Terraform folder that has all of the IAC or configuration as code for your cloud, whatever cloud you selected, for your Git provider, whichever Git provider you selected, for the users that you're managing, and the configurations of HashiCorp Vault. So to create a new SSM parameter set, and I'm going to cheat a little bit and copy some Terraform that I have on my other screen. Copy, boop. And let's go down to AWS and let's create a new file in AWS called ssm.tf. Any Terraform file that's in one of these directories is automatically going to be set up to run. Oops, that was a bad copy.
Wrong copy and paste.
Yeah, one more try there. Copying and pasting is the hardest part of the job.
Yeah, that's complicated.
So this is what it looks like if you want 3 secrets stored in AWS parameter store. So it's of Terraform type AWS SSM parameter. I'm naming them metaphor development, staging, and production. You can name them whatever you want. I'm setting the name equal to a path here. It's important to understand this nuance about SSM parameter store. They'll let you either give it a name or they'll let you give it a path. And if you want to give it a path, then that lets you get a little bit more organized from an IAM access standpoint. So if you wanted to really do least privilege and say that this pod in Kubernetes isn't allowed access to all secrets in AWS, it's only allowed to a certain subset of secrets. Setting it up in a path-oriented way is a really nice way to be able to set up those IAM policies to say, hey, I only want to give it access to Kubefirst, or I only want to give it access to Kubefirst metaphor. Or you can go further to say just development. You can organize those however you like, whatever is most important from an IAM standpoint to your organization. So I'm setting this up with Kubefirst as the top level, metaphor as the second level, and the environment as the third level. You could do it the opposite way and do environment first and then the application name. It's up to you the way that you want to manage it. This is just for the demo. And we're giving them some secret values that are different between dev stage and prod. No big deal. But each one of these secrets say SSM. So our goal for this demo is that Metaphor is eventually going to show us these secrets. So let's go ahead and create a branch. Check it out.
And once you do that, John, just people should probably notice, especially if you're using the SSM parameter store API, because AWS charged through, I never know how to say that word, throughput.
Yep.
So it's available in different tiers, but like just be sure to check the pricing. But I assume if you use the cloud, if you use some of the big 3 cloud provider, you are now used to checking the prices of every little bit. But just wanted to warn people, just be conscious about that. Because you could probably quickly have a beautiful, nice, lovely bill.
Thanks for calling that out, Fred. Yeah, that's really important to call out. And that's one of the reasons that we love self-hosting HashiCorp Vault so much, is because you're free from those nickel and dime charges that the big 3 are a little bit notorious for. All right, so we got our Terraform initialized. And in a moment, saying that it would love nothing more than to create 3 brand new AWS SSM parameters. It's taking its sweet time. Should be here any second. We got any elevator music, Fred?
Yeah, no, actually, I'm going to talk. I'm going to talk instead of the elevator music. You mentioned Civo Navigate. So at the beginning of the show, if you are in Austin, if you're attending Civo Navigate, guess what? You're not going to have 1 person. You're not going to have 2 person. You're going to have like 3 Kubefirst person who's going to be there. So John and Jared are giving a talk on the first day. That's going to happen like on Tuesday. It's from 1:30 to 2 p.m. About 2 p.m. a little after that. And you know what? I'm not totally sure what is the talk. It's let's do it all under an hour. I think it's about Linkerd, service mesh, and stuff around GitOps. So I think that's going to be pretty exciting. And on the second day, so on Thursday, I'm giving a talk named Surfing the Argo CD Sync Waves. So as you guess, it's about Argo CD. It's happening again also in the Legends room. on the Wednesday from 11:15 a.m. to about noon. So come say hi if you see us. We would love to meet you in person. It's a pretty good conference from what I heard. It's going to be my first time, but I heard just good feedback from John and Jared and other attendees. So hopefully we can see you in Austin.
Yeah, definitely. We're really looking forward to it. And I'm actually shocked that you missed the last two Navigates, but you're right. Somehow you weren't at either of them. It is a great conference. We're, just it's a good bit more of an intimate setting. The CVO staff is just exceptionally well organized, and the speakers, they always have really good presence, and there's just always crowds of great tech folks just talking tech together. It is one of my favorite conferences. So
yeah, no, looking forward to it. And unfortunately, there's going to be an in and out for me. So that's going to be my first time in Austin. I'm not going to have time to do a little bit of tourism, but still excited because, the main goal is to go to the conference. And as you said, I just love CVO folks though. So I think that's just going to be a great experience. So Aaron was saying hey, that was going to be my question, is how the secret separator deals with SSM given the default lower tier. So exactly. Even with what I said, go on the pricing page on AWS and be sure you really understand how it's working. And Douglas say it even better than I would have said it myself. Take care of your bills as carefully as you guard your secrets, because yes, you can have that surprise bill at the end. So yeah, please do that.
Douglas showing up. I love it. Yeah, no, definitely keep your guard up on that cloud bill. It will. It has a way of ruining a great month.
Yep.
So this is the result of Atlantis. You're going to see Jared's face in here. He set himself up on this particular stack as the KBot administrator. Typically, when you set up a Kubefirst platform, you're going to set it up with a bot account for that admin. So every time you see Jared, just close your eyes and imagine that it's an automated bot account that you set up when you created your platform. So here's the result of us saying that we would like a new SSM parameter. You can go right down to the line. It shows you anything that's drifted up above. And then down below, anything that it creates, it'll show green. Everything it wants to destroy, it'll show red. And it'll show you changes in place as well. It's going to create these three SSM parameters. I love the plan. Let's do it. Atlantis apply. And when I type that comment, Atlantis is going to run this apply on our behalf. And in theory, over here in parameter store, some secrets are going to show up. So we'll wait until that apply finishes. And I guess while we're waiting for a second there, I did want to call out a couple details about the type here. Now, AWS SSM parameter store has two different types. There's a type that is for a secret, and then there's a type that is just for config. When you set the type to it being a secure string, what's going on is behind the scenes, AWS is going to set up they have a default KMS key that they'll use to encrypt that secret. You can also proactively create your own KMS key and bind it to the secret if you just want really, really, really tight controls over what's allowed to decrypt those secrets. You could go much further than what we're showing you here. But it is very important to call out that the type for the AWS SSM parameter is secure string. And that's what provides you the encryption. Without that property being set, you would still have config there. You'd still be able to pull it. It just won't be encrypted in the cloud. So if you're trying to protect these secrets, you want to make sure that you're doing secure string.
That's kind of a good idea.
Yeah. So we got the, sorry, let me stop jumping around so fast. Over in the pull request here, the plan has been applied and it's been merged automatically. And as a result, when I hit refresh over here, Ta-da. We have 3
Wonderful.
new parameters. And if we click this development one, I do want to, again, pay note to secure string being the type. And as a result, this value has been encrypted, but you can decrypt it right in the console. And external secrets operator is automatically going to do the decryption as well with the default KMS key. So that's all you have to do to get some Terraform as the source of truth secrets into your cloud. Now, the next question is, what are you going to do about it? So we're going to go next, and we have to allow the external secrets operator has no permission in the cloud. As a pod that runs in your Kubernetes cluster, it is not allowed to do anything in your cloud by default. So we have to change that if we're going to keep secrets in your cloud that you need to be able to read from. That means that you need to have a policy that allows you to read your secrets, and you have to bind that policy to a service account in Kubernetes that's running external secrets operator. So let's go through that process. I'm going to go to right back to that same Terraform entry point, the Terraform AWS entry point here. And if we go into the EKS main here, this is where all the configurations about Kubernetes running in EKS are stored. It has a whole bunch of information about, the EKS module itself, and how many nodes you want to be running and what type of node you want to run and details like that. But if you keep scrolling, you'll start to see these sections down below that have to do with the applications that are running in EKS. And you'll see these pairs of policy and service account that where we're establishing that we would like to have a new role with a new policy that's associated with the service account that's running in that EKS cluster. So to show you what that looks like for external secrets operator, and again, if you'll forgive me for copying and pasting, but I will talk through it. Basically what we're doing here, we added 2 resources. The first resource that we're going to look at is the policy itself. We're creating a new AWS IAM policy called external secrets operator. And we're basically giving it SSM get parameter permission for what resource. It's for the ARN of my account that I'm in, and then parameter to represent SSM parameter store. And then there's this /oriented path where we're saying, I would like external secrets operator to have access to everything at Kubefirst/. So what that means is when we're looking at the policy in in the AWS console here, I was talking about that organization hierarchy of being able to establish, what your rules are. This policy that I'm adding is basically saying that anything that starts with Kubefirst/ is going to be allowed to be read by the external secrets operator. Now, how do we bind this policy to the external secrets operator service itself is up here. There's a Terraform module. We didn't write this. This is AWS's Terraform module. And they have a module called IAM role for service accounts EKS. And it's a really nice, easy, friendly way to set this type of least privilege permission up. So we basically say we would like to have a role name, and it's going to be called external secrets operator - whatever your cluster name is. We have this local name variable for whatever your cluster name is. That's our convention for the roles. And then role policy ARNs. We're saying the external secrets operator is the external secrets operator ARN. And then OIDC provider, this is the really important point that you're going to have to update app by app by app. You have to specify the namespace that your service account is in, and you have to specify the service account name itself. So if you were to kubens into the external secrets operator namespace, and then you did like a kubectl get service accounts, it would show you the name of the service account. And these have to match exactly There's no creativity allowed on the namespace or the service account name. So let's go ahead and submit this next. Excuse me. Git add dot git commit. Adding service account binding for SSN and ESO. Push. And let's open yet another pull request. Now, this particular pull request, just to call out the distinction, oh no, I take that back. This is a Terraform change. I thought I had it in my head for a second that was a GitOps change. So here it's going to be going through just like it did on the last one, running a Terraform plan and apply, and then EKS itself will be configured with OIDC access to allow the service account named external secrets in the external secrets operator namespace to be able to assume that IAM policy that we're going to be creating. So we got our Terraform initialized, and then if you wait 60 Mississippi, we should have a good plan back.
You know what? I think I'm going to talk during that time again. So speaking about conferences, CVO Navigate is not the only conference we're going to be there. We're going to be at next week. So for the folks in my hometown, Montreal in Canada, I'm going to be in Kung Fu. It's a 3 days conference. I'm not going to be there on the first day because I'm still going to be at CVO and coming back home. It's kind of like a long flight to Austin with the layover and stuff. But I'm going to be there on the last 2 days of Kung Fu, and I'm giving 2 talks. So on Thursday at 2 p.m. local time in the room Saint Laurent 4, I'm going to talk about GitOps, and the talk is Get Shit Done, the GitOps way. So I'm going to share the love about GitOps. If it's something that is new to you, that's going to be a good place to learn about it. And on the Friday, the last day, right after lunch, I think, I guess so, for the time at 1 p.m. in the Westmount 2 room, I'm also going to give a talk around cloud native. You guessed it. It's going to be bring your Kubernetes games to the next level. And there's going to be a talk where I'm going to share about like CLI tools, like in cluster, like application, whatever that can help you be better when it comes to like using or managing Kubernetes. So on that note, I'm finalizing the talk today. I have a couple of things I want to share, but you know what? There is no way for me to know every tools out there. There's so many. So I'm asking you right now, if you're watching the show, what is your preferred and indispensable Kubernetes tools? Could be like a CLI, like has someone managing a cluster locally. If you're a CLI person, it could even be like I'm always focusing on CLI because I'm a terminal person, but like it can be like a visual tool, like with the GUI. That will be awesome also, or in cluster like application that you feel like every Kubernetes cluster should have it. I still have space for 1 or 2 like tools or things that I would like to share in that talk. And I have my ideas, but I would love also to be surprised and like myself learn about new stuff that I can share with the folks in the room. So on that note, let's go back to trying to do some secret stuff.
Yeah, no, that's a good survey. I would also like to know everybody's thoughts on what the most important Kubernetes tools are. You know, you think you know all of them, and then somebody gives you a gem, and your life is different again. So
exactly.
All right, so we got our plan back. This is going to create 2 resources, or it looks like 3 resources. It's going to create an AWS IAM policy, an AWS IAM role, and then the policy attachment of the policy to that role. So I love the plan. Let's do it. Atlantis, apply. And now we have the ability to actually use that policy in EKS. Now that's still not good enough for external secrets operator to be able to pull from AWS, because we set up external secrets operator a particular way with particular configuration so that it is only allowed to communicate with HashiCorp Vault. So we have to adjust that so that it's capable of interacting with AWS. Looks like that apply went through successfully. Everything's closed and merged.
That's kind of weird to me to see like Jared being like
being the bot. I know.
The bot.
Yeah, no, it's kind of fun. I know he's watching too, so he gets to see his own face just writing comments at blazing fast speed. It's good times. So let's do this. Let's go. We've been hanging out in this Terraform section of the GitOps repository, and that's where all your infrastructure as code is in your new GitOps repo. But there's also this very important registry up here with all of your information about the clusters that have been created on the Kubefirst platform, as well as environments. And we have a loose separation between clusters and environments so that you can move environments around from cluster to cluster really easily. So just a little detail there to understand that nuance. So what I'm going to do is, what's next? I have to update the external secrets operator with a new role arm to use so that it can connect to AWS. So let's go to the management cluster, which is where our external secrets operator lives. And in components, external secrets operator, there is the configuration for how we install external secrets operator to your cluster here that service in when you're only connecting to HashiCorp Vault. Now, if you need to connect to AWS instead, it needs to look just a little bit different. I'm going to copy and paste one more time and drop those in here. Looks like the service is right under the letter L, and it remains that way, so we're happy. So we're going to change that so that it's a service account that's being configured, and instead of create false, it's now create true. We're going to give it a name of external secrets, and you probably recall just a moment ago that was a really important detail about the service name right there. That's the value that needs to match the name of the service account that you're creating there. And this is being created in the external secrets operator namespace. And that's why this value here is external secrets operator. So just so that you can connect those dots together. And then for the service account that we're creating, we're going to annotate it. And when we annotate it, we're basically just dropping some text on the service account object and saying we would like EKS to assume a particular role when this service account is running the pod. So let's take a close look at that before I apply this. Let's go to Argo CD, and I'm going to pull up external secrets operator after I log back in. Okay, so external secrets operator. And if we were to look at the external secrets operator pod here, and just kind of look at the live manifest, I want to call out before we make the change that in the spec, there's no AWS-oriented environment variables. But when we make this change here and add this annotation, it's going to do some EKS magic that's important to understand from a OIDC least permission IAM access standpoint. So let me push this up and get it in. Git add git commit adding service account for ESO to use AWS role. And that is pushed up, and let's get a new PR, submit it. And this one, this is a GitOps change. This is not in the Terraform directory. And as a result, there's a couple little jobs that will run real quick just to check syntax. But this is not going to run in Atlantis plan for you because there's no Terraform being changed here. So that's an important distinction when you're submitting pull requests on the Kubefirst platform. Changes that are in the Terraform directory are going to invoke the Atlantis workflow. Changes that are not in the Terraform directory are your typical GitOps, where as soon as it hits the main branch, it becomes actualized immediately.
That makes me think, Sean, that like I will probably update the action so like it's not running when it's not like a Terraform file. So like I know in the end it wouldn't like change a lot of things because there's still other jobs to run, but you know, it's me. I just like, hey, if it doesn't have to run and we can save a couple of seconds, why not?
I bet it's in our next release. I bet our next release happens in the next day. I bet it does. What do you think?
Would be nice.
Let's squeeze it in. We can always squeeze one more thing into a release, can't we, Fred?
yeah. I'm a little less worried about squeezing things in a release. It's like squeezing a release within the week we're having right now.
I know. It's been a doozy of a week, hasn't it? So here's our change set. Looks great. I don't need no stinking reviewer. Let me just merge. And when this hits the main branch, let me go to applications and just refresh all of the apps so that I'm sure that all the layers get updated with the latest changes in the GitOps repo. That's a little slower than usual. Come on, little buddy, we believe in you.
You know what? I'm starting to like that music.
It's great.
At the beginning, that was a joke, and like, I need to have something where something wrong's happening, or we need to debug live. That's just gonna be funny. And now you request it when we were waiting on something, and actually, I really liked it right now. I'm just like really like stupidly dancing, but
I know
I just like it.
If that was volume 5 for that track, if we could just reduce it to like volume 2, I would love to have it go through the whole live stream. Just background love and enjoyment and satisfaction. In fact, it's a very similar soundtrack to Flappy K-Ray. It's got the same vibe of just, it's almost like you're on vacation. It's nice.
It is.
Yeah. All right, let's look at you, my MC. Love it. We're all refreshed everywhere. And let's go ahead and take another look at that external, if I could spell, secrets operator application. And here, let's see, I'm going to restart. I'm going to restart this pod so that it can refresh with that annotation that we just set. You do need a restart in order for EKS to allow some new environment variables into that pod. And when we look at it this time, if you look at the spec, now there's these environment variables that have been automatically added to the running pod. And these are the environment variables that allow it to assume the external secrets operator management live role that we just created a second ago. So that's implemented using a admission webhook, and just important to know that detail. You need to restart the pod after annotating it so that it has a fresh opportunity to pull those environment variables in from the admission webhook when it tries to provision the new pod. And so that's all that we need in order to allow the service account to now reach into AWS. And we've already set it up so that it has the right policy so that it can pull secrets from Kubefirst/anything. Now, the last two things we need to do is we have to create a new secret store, which is an external secrets custom resource. And that secret store we're going to say there are secrets in AWS that we would like to be able to read from. It has no detail about which secrets. That's a different custom resource called the external secret. So first, let's work through the secret store. The secret store is pretty easy to configure. And again, forgive my copy paste. I'll tuck through it one more time. We're going to go up to clusters, management, and in management, we have a cluster secret store folder and a cluster secret store YAML. Now, this cluster secret store is the one that you get by default that allows you to connect to HashiCorp Vault. But what we're going to do,
I should probably have said something sooner. Can you zoom a little bit?
Oh yeah, thank you, Fred.
Yeah, wonderful. Thanks.
Yep. So up here, this is the one that comes with the Kubefirst platform. I just pasted this triple dash in order to create a file separator in YAML. And then I'm adding another cluster secret store. This one, unlike the one above that's called Vault KV Secret, we're naming this one AWS Secret Store. It's a parameter store service, and that's an important distinction. If you copy and paste from their site, they're using secret manager instead of parameter store in their docs. Change that to parameter store if you want to use SSM parameters. And it is important to get the region right. When you're storing secrets in AWS, you can have two of the exact same secret in two different regions with two different values with the exact same name. So it's always important to specify your region when you're reaching into AWS to pull secrets out. And let's go ahead and commit this and get ourselves a secret. Well, actually, let's do them both in the same pull request. So the next thing that we're going to do is add a new external secret to Metaphor so that it can pull from this external secret. So in order to do that, I'm going to go to the not clusters, but environments. Environments are where all of our application environments are. And we're going to get a development metaphor here. And the metaphor chart is just a chart. And what that means is that we're allowed to extend the chart by creating a templates folder. And I'm going to add that folder and create one new file in it called external secret YAML.
If you are curious about, like I know John said it a little bit, what is Metaphor, but guess what? We also did a full live stream on Metaphor. Again, sorry, I need to finish the installation of my shortening URL tool. But yeah, just go on our YouTube channel, look for Metaphor, deep dive on Metaphor, and you're going to learn everything about that application, which is pretty good if you want to learn how how to use basically the Kubefirst platform once you have Kubernetes cluster.
100%. Yeah, we love Metaphor at Kubefirst. It's a great little app, and you know we use it for demo purposes a lot, but we also use it operationally internally whenever we want to make CI changes and you want to test out how that works. Using Metaphor as that vetting ground for the changes that you're making means that you have a real application that you're delivering to real clusters that use your real CI, but you can change the CI in an app that is not going to impact your development team, because experimenting on CI changes on an actual live app that your developers depend on to be able to deliver to development staging production, get their releases out the door. You start messing up their CI workflow and you get grumpy developers. They don't like your platform anymore. Everybody cries. So let's not do that. This is a new external secret object. We're giving it a name of development environment Metaphor, and it's important to call out that that matches exactly the secret that Metaphor is looking for in the development environment. And we're saying that we want to pull a couple secrets. We're going to use the AWS secret store, which we just created in that last file that we were looking at. It's of kind cluster secret store. Important to call out that there is a secret store that's namespaced, and there's a cluster secret store that's cluster wide. We're using the cluster secret store. It makes it a little bit more frictionless to use. And then for the target name, this is the name of the secret it's going to create. And we're saying, hey, go into AWS, reach into Kubefirst metaphor development, grab secret 1 and put it in the secret that you're going to create in Kubernetes as secret 1. And similarly with secret 2 from AWS, we're going to put that in secret 2. So pretty simple. Git add ESO custom resources. Git push. And this is the change set that we're looking at here. Again, we're creating a cluster secret store named AWS secret store, and then we're using it down here in the metaphor development environment. One more change I need to make is that metaphor by default comes with an external secret already that's set up for HashiCorp Vault, and we have to turn that off so that it doesn't collide with the one that we're creating right here. So in order to do that, we just have to go to metaphor development's values YAML. And down here at the bottom, there's an use external secret true and a use native secret false. If that was set to true, it would just create Kubernetes secrets without any external secrets at all. I'm going to turn external secrets off. A little counterintuitive because we're still using external secrets. We're just using a different one. So when I change that to false, and we're going to keep native secrets set to false, I need to add that as well so that there's no collision.
And that's still going to work even if we turn off use external secret.
That's correct. That's correct. Because we created an explicit external secret object here.
Okay.
So we're not going to use the one that comes with metaphor. We're instead going to create our own, and it looks like this.
Makes sense now. Yeah.
Cool. So let's go ahead and merge that guy in. Refresh. So now we've got 3 changes, including turning that off. And let's merge. Okay. And now when we go to, let's go to development. Actually, let's go to metaphor development. And when I refresh this, what happened here? Could not get secret data from provider. I know, it is sad. Secret synced error, false. So let's look at external secrets operator pod itself and see what it's doing. So if we look at the pod logs, hopefully this will be enlightening. Could not get secret data from provider. Development, environment metaphor, cluster secret store, AWS secret store.
Oh no, okay. I thought you had a typo, but you're good.
AWS secret store not found. That is interesting.
Ladies and gentlemen, that is the awesome world of live demo.
I know. I really thought that was going to be a slam dunk. Let's do some debugging live. How about it? So let me give myself a new terminal. Oops. And let me zoom up a little.
Sean knows I don't like the. I like colorful things, but like I'm really basic when it comes to terminal. I mean, like the background needs to be black.
So first I'm going to assume into my AWS account, and then I'm going to run AWS EKS update kube. This is exactly right. And then I'm going to, let me kubens to, where am I going to, let me do a k get cluster secret store in all namespaces. There is an AWS secret store, so I don't know why Metaphor is struggling to find it. Let me double check my config on the secret store itself. It is an AWS secret store. It is a cluster secret store, which is correct. And then Metaphor, this cluster secret store name is irrelevant to us because we are not using the external secrets.
Jared's saying it's LT now.
Oh, is it?
So yeah, maybe it was just a sync issue.
Yeah, maybe I probably should have refreshed everything. Maybe it was the parent components that needed to be refreshed in order to get the update. In any event, let me go back to Metaphor and check it out on screen. And yeah, it is healthy now. So maybe there's a 10 Mississippi thing.
Yeah.
When you have to, after you make that adjustment. But in any event,
Jared is telling me in private that he did not modify anything. So it's not some black magic behind the hood. Sometimes Jared just goes and it like he fixed things live and like, oh yeah, no issue anymore. But like it was just, a sync issue.
All right, so we've got this external secret. Just to inspect it real quick, there were a whole bunch of events for a second, but they have not happened for the last 3 minutes. So I guess if it turns up red, just give it a healthy 100 Mississippi and then look again. And this is creating a secret, and the signature of the secret is identical to what we did before, where it's secret 1 and secret 2, and it has some values. So now, in theory, if I were to, this Metaphor pod right now has not been restarted. So even if I were to refresh here, this still has old values of development secret 2 livestream that came out of Vault. How do you get those new values in? It's always by restarting the pod. When you restart the pod, it gets a fresh opportunity to pull the secrets out of Kubernetes and hydrate them as environment variables in the application. So let's go ahead and restart this pod. You can also use Reloader to restart the pod automatically if you want that to be the behavior of secret changes. So in a second, this guy's going to be running, and then another 10 seconds, and it's going to show healthy and 1 out of 1.
Right and Reloader is what we use for managing like our secret change, like by default in Kubefirst. Now you had to do it manually because like we changed the secret store and
right.
Yeah.
And so now if I were to go here and refresh, now that we've restarted the pod, we have some different values down here.
I need to cut that sound. Like people applause for way too long. I mean, don't get me wrong, it's nice, but like it's a long.
I know. It's almost like I got awarded an Oscar or something. the length of that applause. Like you got to give me time to walk down the aisle and accept my trophy. But yeah, so that's basically the whole story, Fred. So in summary, we went through. We had to create a new external secrets operator role. We had to create a new policy for the role to leverage. We had to, let's see, let me not. So we had to add the parameter secrets themselves to the cloud. And then we had to update external secrets operator so that it could use a new role ARN so that it could leverage that ARN to assume the role, to get the policy, to be able to pull the secrets out of the cloud. If it starts to sound exhausting, you should just use HashiCorp Vault. It's way easier. Then we had to restart the external secrets operator pod so that it could get those AWS environment variables through the admission webhook. And then we had to add a new AWS secret store. We used a cluster secret store so that it was available to all namespaces. And then we created a new external secrets object so that Metaphor could get those secrets out of AWS and make them available to Metaphor as environment variables. And that's basically the whole story. If you wanted to do the same exact thing in GCP, the Terraform is going to have slightly different names. It's mechanically, it's going to work identically. If you have older apps and they just have swaths of secrets and configuration, and they're all over AWS SSM parameter store, and like adopting Kubefirst was just felt wrong because we use Vault, and you have hundreds of applications and they're all using SSM parameter store or whatever. Everything about the Kubefirst platform is all configurable because we give you that GitOps repository, and you can just change whatever you want and pull request the changes that you desire and turn our platform into your platform. So I think that demo sort of demonstrated that from a secret standpoint. It doesn't just apply to secrets. It applies to, CI. If you don't like workflows, if you don't like GitLab, if you don't like GitHub, if you don't like whatever, you can change it to Circle. You can change it to Drone. You can do whatever you want. That's the show, Fred. Why don't you bring us out?
That's amazing. And you know what? I feel like I don't want to have things on your plate, but like I feel like that live stream could be a really nice blog post, a little bit like what you've done with the GitLab. Maybe not today, maybe not this week, maybe not even next week, I guess, because that's going to be a busy time. But I feel like that could be something really, really interesting to have like in a written base. Or even I mean, like now that I got the video, I had no idea how to do that, but now that I listened to you for the last hour, I mean, like now I know how to do it. So even myself could write that. So just saying that, like maybe at some point we're gonna have it on written form. So no promise,
absolutely.
But like I think it's a thing that could happen. And thanks, Douglas. Great job, guys. Keep it going. Love that. We love that. Thanks everyone for joining us. And John, do you know why do programmers put two glasses, one full and one empty, under bedside table before going to sleep?
Jeez. One glass half full. No, one glass full, one glass empty?
Yeah.
I can't pull it. What is it?
They have one glass in case they get thirsty and one in case they don't. And yes, ladies and gentlemen.
There it is. Sending us home proper every single time. I love it. I love
alternative ending to avoid overflow. Love that too. And yes, Douglas, I don't know if it's the first time you're joining the live stream. It's now a thing since I guess I joined the show.
Yeah.
And the story was just because like on the first show, I was like, okay, I can be on the live stream, but like I don't know Kubefirst. I don't know most of the tools we're using. I'm just gonna be a brave face. So like I need to bring something to this show. And I'm like, okay, let's just stupid like developer joke. And weirdly enough, people loved it. And now like it's a giving. I need to do that at the end of every show. But actually, I kind of love it. I think I'm at the age now, like I can like honestly, and I have the right to do dad jokes like that. That's like developer dad jokes. So yeah. Anyway, on that note, thanks everyone for joining. It's always nice when you're commenting live, when you're asking questions, where you're like just like being in the live stream with us. We love that. For the people watching the recording, thanks also for you. And we're gonna see each other maybe in Austin, maybe at Confu in Montreal, and if not, on our Slack community or in 2 weeks for the next live stream. So
that's right.
Have a good rest of the day, everyone.
Thanks, everyone.